going to talk about slopes of parallel and perpendicular lines today. And yesterday what we talked about is how to put a line in point slope form. And now we're going to apply this idea to other types of lines like the parallel lines. So it's kind of hidden in these notes, so that's when sometimes it's helpful to use the highlighter here. But parallel lines are lines in the same plane that never intersect. That's the technical definition. And usually what you think is they never cross. Parallel lines never cross, which is words in student terms. And in geometry, the way that we look at it is two non-vertical lines. So vertical, remember, is up and down. So two non-vertical lines will be parallel if and only if their slopes are equal. Again, not a fan necessarily of highlighting, but this you might want to highlight. You might want to think about underline. If you don't have a highlighter, I've got my colored pencils up here if that's helpful. Parallel lines have the same slope. That's why it's in bold. If we take a look at our examples here, there's my directions. Determine if the following lines are parallel. Well, these lines in particular on A and B are in slope-intercept form. Again, what we talked about in our previous notes. And what we can identify here, just a reminder, slope-intercept form is y equals mx plus b. So the m, what's the equation to solve for y? The m is the number in front of the x. So in this particular case, the slope is 1/3. If we look at this second equation, y equals negative 1/3 x plus 15, that's y equals mx plus b. In this case, our slope is negative 1/3. But in order for two lines to be parallel, those numbers have to be exactly the same. So one is positive, one is negative. So no, this is not parallel. If you're not familiar with the formulas, again, what I recommended to you yesterday is that you write down the formula every single time so that you remember the formula. Not going to be provided for you. Point slope, not going to be provided for you to the best of my knowledge. Slope-intercept form, not going to be provided to you for the best of my knowledge. So we need to know them. And in this case, our slope is 2 for our first line. Over here, our slope is not y, but m. The abbreviation for slope is 2. And what we see then in this one is that the slopes are exactly the same, which means that they are parallel. If we look at letter C, the nice part is on the first equation, it's in slope-intercept form. Y equals mx plus b. Something that you talk about in Algebra 1 a lot. But our slope on this particular problem is 1/2. Over here to the right, we cannot identify what the slope is until we rewrite the equation in slope-intercept form. And what we did in our previous notes is we said when we're putting these in slope-intercept form, we have to solve for y. So we're going to subtract 3x from both sides. And we come up with 6y equals negative 3x plus 18. Then it's 6 times y. We're going to divide both sides by 6 to undo the multiplication. And by the way, negative 3/6, if you need to, you can type it in your calculator, is negative 1/2 x. 18 divided by 6 is 3. And then lastly, what we need to take a look at here is, well, what's the slope of this line over here? Here's y equals mx plus b. And what we see is that the slope of this line is negative 1/2. Negative 1/2, positive 1/2. No. Parallel lines have the same slope. Last two examples on this idea here. These two, on letter D, and even on letter E, our equations are written in point slope form. Point slope form is y minus y1 equals m times x minus x1. Again, I can recommend, if you are not familiar with that equation, that you write it down every single time so that you don't have to memorize it later. And what we have on here in particular is we want to identify what's the slope. And what the slope is in this equation to the left is 4 fifths. Here's our m. It's in the same place on this second equation. Here is our m. M is the abbreviation for slope. And as long as those values are the same, then yes, they are parallel. Parallel lines have the same slope. Lastly, can we take a look at this one? Y plus 4 equals negative 7 times x minus 6. Well, y minus y1 equals m times x minus x1. Our slope in this particular part is here. And it's here. It's the coefficient, the number in front of the parentheses. To the left, our slope is negative 7. To the right, our slope is positive 7. And again, parallel lines have the same slope. So this is no. Example number 2 is a multiple choice question. Which of the following lines is parallel to y equals 2/3 x minus 1? The first thing that we can look at on this particular problem is, well, what is the slope of this line that we're working with here? And because the equation is solved for y, our slope is the number in front of the x. So our slope, in this case, is 2/3. And down here on our multiple choice, we have to put these equations into slope-intercept form to identify whether they are parallel or not. But the good news is Desmos could also be a help. Like, you could type this equation into Desmos, and then type this one into Desmos. Did you get the same slope? And you could count. But since we're looking at this here, and I don't have Desmos open, let's put this in slope-intercept form. Good practice, if nothing else. So to put this in slope-intercept form, we're going to subtract 2x from both sides. And we end up with 3y equals negative 2x plus 12. And then we can divide by 3. So we get y equals negative 2/3 x plus 4. And maybe you didn't even need to do that last step. Because once we solve for y, what we know is the number in front of the x is our slope, and negative 2/3 is different from positive 2/3. So it's not A. If we look at letter C, I just went downward here, and it doesn't matter. Oh, wrong one. But if we solve for y, we can add 4x to both sides, and I know I had to squeeze it in 2, but we get negative 6y equals 4x plus 6. When we divide both sides by negative 6, the one thing that I notice here, even without simplifying, is that this value right here is negative. And the slope that we have up here is positive. So without simplifying, I can say, yeah, this is not the answer. If I can get there. But if you are somebody who likes to have closure there, this ends up to be y equals negative 2/3 x minus 1. So if we switch over here to letter B, putting this in slope-intercept form, we can subtract 4x from both sides. It's going to be a tight squeeze for me. We get negative 6y equals negative 4x plus 24. And luckily, I think you can go like this. I cannot. But if we divide by negative 6, what we end up with is we end up with y equals negative 4 divided by negative 6 is 2/3 x. And 24 divided by negative 6 is negative 4. What's our slope in this problem? It's 2/3. And it matches there, and we found it. Again, Desmos could be a good way to find your answer as well. Maybe faster. We flip our paper over. There's the parallel lines. So now let's talk about perpendicular lines. And the difference on perpendicular now is two perpendicular lines that are neither vertical or horizontal have slopes that are opposite reciprocals. Well, opposite means that you change the sign. Reciprocal means that you flip the fraction. And that's what this is saying down here. The term opposite reciprocals refers to two numbers that have opposite signs and are flipped fractions. So again, not a huge fan of highlighting or underlining for that matter, but this might be a time, especially if you're not familiar with this concept. First, to be opposite, they have to have different signs. One number should be positive, the other one's going to be negative. Second, to be reciprocal, one number should be flipped fraction, or the upside down version of the other number. So 4/5 has an opposite reciprocal of negative 5/4. We flipped the 4/5 and we changed the sign on it. One little thing, just in case I say it on a video, is that I sometimes use the word negative reciprocal, which means the same thing. So we get close to finishing here. Our multiple choice question says find the opposite reciprocals of the following numbers. And it's not multiple choice, sorry, it looked like it for a minute. But the opposite reciprocal. Once again, we flip the fraction, so 3/2 becomes 2/3. And we change the sign. You don't have to write the plus. I'm just going to put it in there to show that we changed the sign. Remember that 5 is 5/1. So when we find the reciprocal, we're going to flip that value. So it's going to become 1/5. There's the flip. And then the opposite is we're going to change the sign. So 5 and negative 1/5 are reciprocals. Letter C, negative 1/3. Well, let's just deal with the fraction here for a minute. The reciprocal, we flip it. 1/3 becomes 3/1. And then we change the sign again. No, you don't have to write the plus. If you prefer, the answer is just 3. 3/1 is 3. And lastly, letter D, negative 1/1 is how we can write it as a fraction. We're going to flip it. Well, that becomes 1/1 again. And then we change the sign, so it was negative, so it's going to become positive. If you prefer, this is just 1. There's our reciprocals. Now, like we did on the front, we need to determine whether these lines are parallel or perpendicular. And what happens here is we need to look at the slopes. Once again, do you know the equation? Y equals mx plus b. Y equals mx plus b. Our slope of the equation to the left is 2/3. Our slope on our equation to the right is -3/2. Did we flip? Yes. Did we change the sign? Yes. These are perpendicular. 2/3 will become 3/2. It was positive, so it's going to become negative. Opposite reciprocals is what the perpendicular is. Letter B. We can identify our slope on this one, on the equation to the left, because our slope is the number in front of the x, as long as the equation is solved for y. But on our equation, oops, they are both solved. I misread that. Y equals mx plus b here. Our slope on the equation to the right is 5. If we prefer, we can write this as 5/1. So they are reciprocals of each other, but they're not opposites of each other. And because they're not opposites of each other, these are not perpendicular. Letter C. The equation to the right, we can identify the slope. So we have y equals mx plus b, and our slope is -3. And if we prefer, we can write it as -3/1 because slope is rise over run. But we have to solve to the equation to the right. We have to solve for y, put it in slope-intercept form before we can identify whether we have opposite reciprocals or not. So we're going to subtract x from both sides. We get -3y equals -x plus 12. And then we're going to divide everything by -3. And we end up with y equals. And just a reminder here, when there's no number written in front of the x, it's a 1. So what we have over here is -1 divided by -3, which is positive 1/3 x. And then positive 12 divided by -3 is -4. We solve for y. And now we can identify what's the slope of this particular equation. And we see that it's the number in front of the x, which is 1/3. And then the question becomes, are these opposite reciprocals? Well, one slope is negative and one's positive. So yes, they are opposite reciprocals. Did we flip one to the other? Yes, which means these are perpendicular. Our last two equations, once again, are written in terms of point slope form. And our point slope form is y minus y1 equals m times x minus x1. We need to identify the slope. And the slope in this equation is here. And the slope in this equation is here. And then we're comparing. Well, the slope, -2, if you prefer, it's -2/1. Our slope in our second equation is 1/2. Opposite reciprocals is what the relationship is between perpendicular lines. Well, we did flip the fraction. 2/1 became 1/2. One of the slopes is negative, the other one is positive. That means yes, these are perpendicular. Same idea here on letter E. And we're looking at these values right here. our point slope form, just in terms of hopefully helping you to remember that equation without physically sitting down and remembering it, memorizing it. But what we have is that our slope of our left equation is 5/2. And our slope of our right-hand equation is also 5/2. And because they're both 5/2, what we get is that these are parallel lines because they're the same slope, not opposite reciprocals that we want for perpendicular. Lastly, a good OST question. It did not print very well. Not on your paper, not even up here. But it says, oh darn it. Sorry, RQ. I messed that up. RQ is 3/4. Step 4 very well. RQ is 3/4. So what we need to know is, well, where is RQ over here? Because like I said, it didn't print. It printed a little bit better here. But here's R, here's Q, here's S, and here's P. If you need to add that label in there. RQ is 3/4. And what we're looking at this segment. So from here to here has a slope of 3/4. And what we want to know is, well, what is the slope of RS? And I actually covered it up, but there is a box in that corner. And that box means that these two lines are perpendicular. And that box means that we intersect at a right angle. So if RQ is 3/4 and we have two lines that are perpendicular, what we need to do is we need to flip that fraction. There's the reciprocal. And we need to change the sign.